So now let's make this part using parametric equations using inches. So we're going to say File, New. And this time we're going to go back over here to English and select inches, create. Now we have this shape that kind of looks like an H out here in the front. We will sketch that one first. We could try to do things like using some symmetry about there, but how about we do this a little bit different this time? So let's start with just this horizontal distance, which is 1.25. Now, if you have the line tool, what you can do is start here and just kind of put it up like this and purposely make it not correct. And then you can, maybe make a line of symmetry going up and down. So like this right here, going up and down, make that one right there hidden line so that we can use it as a reference. And then when we want to center this up, we can go like that, and then control click right here, and we've made those centered up. Another way to do that, hit Control Z a couple times, is we're trying to get this new feature for everybody that says midpoint on all these computers. If you don't have that, you'll have to do it the other way, but look at this midpoint control. I don't like the fact that it was not letting make it horizontal, but there we go. And the distance that we want this one to be is going to be 1.25 inches. Now it's got too many digits past the decimal, so remember to go up here to Tools, Document Settings, Units, and let's scroll back our roll back of our number of digits past the decimal that we are displaying. Okay, let's see. So go ahead and finish that right there. I guess I shouldn't have finished it so soon because I'm still editing it. I was trying to get some of this automatic features turned off because I noticed it wasn't really letting me um, enter the dimensions right away. Now, we don't want to do center of midpoint all the time. So what we're going to do is just draw out the shape. There's the foot over here, and it's not really at the same level. So let's make this lower than the other one. And going up like this. And we also notice this is not directly above it also. So we'll pay attention to all those things as we're roughing it out. I was going to say we can probably just make a um, mirror image at this point, but I'm going to continue on and use some constraints for my mirror imaging instead. And you'll notice that what I'm going to do is try to lock it in here because I know it's symmetric that way. And coming back over here, we should have a closed shape. So let's go ahead and make everything, fully defined. So first of all, we can see some symmetry. I don't really think that we have to tell it that those two things are equal to each other. It already knows that. But these two right here need to be equal. Okay, let me select that again. So this one and this one need to be equal. There and there. These two at the top also need to be equal to each other. It probably already knows that these two are equal. Yeah. And these two are equal. Sure. Okay, so it's got some of those already figured out. Let's start defining some of these heights then. So we can say that this one right here is 0.75. And so that appeared to be a little bit unexpected because it didn't really want to put it at the origin. So it didn't really move this one up from the origin. Instead, it moved it down. So when that kind of thing happens, what you can do is hit Control Z. And also we notice that there's a part missing right here as well. Is what we can do is finish making the line for that part rather. And then we can tell it that we want this one to be along. So I'm going to do a control click around the center. We want it to be horizontal about that point right there. Now, if we change this one right here to 0.75, it should drive it up, but it certainly did not. So we'll try that again with this one and this one being horizontal. Didn't really want to move it up, did it? How about we do it instead this way? Um, hmm, yeah, that's kind of weird. Now that I think about it, let's do it this way instead. Let's remove that 75 right here. Yeah, that is odd. It looks like there's a point right there as well. Let's try some other dimensions and then we'll come back to that one. So this one right here, we've found to be half. And that seemed to be, some good symmetry happening there. And the width of this needs to be 1. And the width of this one up here turns out to be, looking at the diagram, not really seeing that one very easily. So we're going to assume that it's therefore inferred have the size of that instead. And so we're going to delete that one and assume that it kind of works itself out based on what this one is. Now we're going to assume this is in the middle of that. So we're going to take 0.375 and multiply by 2 for that center point right there. So let's see if that's going to work out. 0.375 times 2. Like so. And that one over there changed as well. You can see that's 0.75. Oh yeah, it looks like it didn't even center this one up as we had planned. So let's go ahead and, yeah, I guess right click on this one. Let's see, right click there and there. Let's make those a vertical. So there's the option right there. So that brings that in. We can also do the same thing for this one if we can find the center. So maybe what we can do is click on this tool and see if it will let us find the center first, and then find the origin. Control click and bringing those into symmetry. All right, let's get some heights going on here. There's 2 inches all the way up from here. So we got that one. Put that right out here. And how many dimensions do we have to go? It looks like about 6 more. All right, so that's 6 right there. Let's see, 2 there. And this width does not look right there. So we will keep that in mind. Oh yeah, we have the entire width that we haven't really put in there, and that's 3.5. So since we're in dimension mode, we'll go here to there and 3.5. Still looking not correct as far as the width on that. So you do want to pay attention to, your visual clues here when you start to see these things. If it doesn't look symmetric, you want to give it a little bit more thought to it. Okay, so where should we head next? Looks like we got a lot of these dimensions in place, only 3 more to go. So we can use our clues here, hit escape, and go up to show all degrees of freedom. And you got a lot of motion here. So it looks like what it's telling us is that this part is not really centered at the origin just yet. And so that means if I took this, I should be able to move this entire part left and right is basically what I was seeing. But that's not what it's indicating here. This one seems to be going up and down. So that one's not constrained to be along the horizontal axis just yet. So that's another one we need to look at. Yeah, so check this out. You can hit this and you can see that I got a rotation problem also here. So I Control Z on that. And let's go Control Z back to this one. I think I had the video off when I was showing this part. We want these things to be horizontal at that point and this point right here. We also want this to be horizontal, and that's what we were really looking for. Now, hopefully, we can go back to this point that we originally did and make this right here 0.75, and it will drive the part up instead of down. So it's about establishing that anchor to begin with, and now we have a fully defined part. What we can then do is before we start to extrude this, is to establish some of these connections if we can. So we see that they're all dependent upon D, which is the height right here. So let's look at part A over here. And the height of D is that 2 units. So it's called D6. And so we want A over here, which is going to be this one. We can move it over. We're going to say it needs to be D6 times whatever the relationship says right here. And that is 0.375. We want to make sure that that remains 2, and this remains 0.75, but then there's a functional relationship between the two, so that if we increase this one to 3, it also increases this one by the appropriate scaling factor as well. So we got one of those down. Let's go in here and do a D6 on this one. D6. And then what is the equation for B? It needs to be divided by 4. This needs to be 1/4 of that value. And so 1/4 of 2 should be 0.5. And so we see that now it's a functional relationship as well. This next one is actually deeper into the part. So we'll hold off on doing part C until we get the part extruded. So let's extrude this, and we want to take that shape. And how far are we going? Basically 2 times this distance right here. So going like that, and we're going to say 0.625 times 2 within the equation. And there we go. Looking good. And we can start to put some holes down on this surface here. So yeah, I guess we can go ahead and let's try to do it on this side and then mirror it over on the other direction. So let's right click here and go ahead and create a sketch right there. And it's going to be the circle that we see as well as the triangle. So we could say, let's make it a midpoint there, but let's just not assume that's the case. It looks like I got my locking feature in position here. The snapping going on like that. Let's go ahead and be really clear about where we want this part to be. We want it to be a distance of 0.375. Okay. It looks like I needed to really show another dimension. So let's go back in here. Units, let's crank this back up to that one right there. Good. All right, and then this other one, if we are in the dimension mode still, is going to be relative to this axis, and it needs to be half of the entire thing, or as it says over there, 0.625. Okay, so as you can see, one of the problems I'm having here is that as I am going into dimensioning, normally what would happen is it would come out here and it would prompt me for the dimension. So it's not doing that anymore. So what I'm going to try to do is use what's called the Autodesk Inventor reset utility. So if you have some behaviors in your application that are unexpected, you may have accidentally turned some things on, which is apparently what I did as well. Let's go over here and just temporarily save this file, and I'll show you how to run this utility. So it says right here, I need to go ahead with that. And then we're in chapter 5. So we want to make sure we save this one as part. What do we have over here? 5.2. How convenient. There we go. And then we could do is close that right there. Close that other part that we did. Make sure to save this one as 5.1 from the previous video. All right, so we're here. Now what it says to do is you can go down underneath the start menu. So let me close all of that down. Come back to D2L as well. Going over here to the A's right there, there should be a utility that says Inventor Reset Utility. I've never really run this one before, but let's see if it will solve my problem in particular. Okay, so it looks like it's reset everything back there as we wanted it to. I'm going to restart Inventor to see if that helped with my dimensioning behavior. Now let's just see how far back it went on the reset. It did save the chapter 5 items there. Hopefully they're still in the list. I do not see them. So we'll just pull it up like this instead. And let's continue with the dimensioning of the part and see if we've solved some of our problems. We can right click on this and edit this sketch, or we could go over here and edit the sketch and double click on this right here. And that needs to be 0.375. All right, so that's good. And then the next thing we want to do is make a triangle out here. And we want to make sure it's a closed triangle that we can cut through. And we need to make sure that each side is 0.3 units. Now we're finally going to see, is this going to give us, is it going to prompt me for the dimensions? And it did. So that apparently that reset utility worked. So the lesson learned here is that if you have a behavior happening within Inventor, just go over to that reset utility tool. I'll try to remember this during class as well, and see if that helps us get back to a more familiar environment and behavior within the application. Let's do some cutting through that part there, and also see if we can do that one as well. At the same time, we can just say through all would be sufficient. We don't want to get carried away with it and go way out into space for no reason. You can orbit over the top to make sure it's a through all. And then you can select on that thing, which is actually two cuts down, and make a mirror image of that. So we want to make a mirror image of that three-dimensional action. I guess it's not really a part, but a lack of that, or a cut rather. Okay, so then we want to look for the mirror option, which is right here. It's basically saying, well, what do you want to mirror it about? I always like to go over here and hover over these until I can visualize which plane it is. And so we've already kind of highlighted the feature. Now we want to get the mirror plane. It's going to be that one right there. You can see that it highlighted what we're about to do. We commit to that, and look at how easy that is. So it took me longer to explain it than to actually do it. As you can see, sometimes that happens. We got two more things to do. One of them is the placement of this hole. The other one is the arc. And of course, all the way, the cutting all the way through as well. So let's draw on this face. New sketch. Coming down to this area, zooming in. Purposely putting that circle way off center so that you can force it to be in the center. The other thing to do might be if we can kind of find the center there. I don't know if it's going to let me do that. Okay, there it is. Sometimes when you find it, then it'll draw that line right there. It's going to let you put that on the midpoint. Let's see if that's indeed what happened as we go from here to the center. Do we know how far down it is? Well, it's probably better to go up because it says 1.5, and that is the other parametric equation we need to draw anyway. So go here and then way down here instead, and we'll call that 1.5. Come back and we'll come back and put the parametric equation in there in a moment. And are we given the diameter of the radius? Looks like we are given the diameter of 0.5, so we will go like that. I'm surprised that it didn't make it fully defined, so maybe it didn't realize that we put this on the center. So we will convince it that the distance over there is 0.625. Okay, well, I guess that was it. And then what we can do is make this arc at the top, which has a radius of 1.5. That's a kind of a big arc to it. So we can just put our arc down here. And again, I like to go, a bit off on this so that you can follow these constraints. It's going to be going from somewhere here to somewhere over there. It doesn't look like it wants to even lock into that one necessarily. Okay. And then some of the things we can do are, I guess, make this one tangent there. I don't know if that's going to be good enough. So let's make ourselves a bisector. And so we're going to say a line going from the midpoint here, there's green, to the midpoint down here. Kind of a reference line. We don't want it to be part of the part, so we make it a hidden line. Then we can make the center of that big arc coincident with this line. Looks a little bit better. It's still not connecting all the way over there, but you know what to do, right? Just hit escape. And we say we want to make that point coincident with this line. There we go. And hopefully it already knows that this point is coincident with that one. Yeah, it already knew that part. Then finally, we can make this right here tangent with the top. Let's see. There we go. Tangent. This one and that one. Yeah. And I guess the reason why it's still purple is because we haven't told it that it needs to be 1.5, like so. And just to show you, that's not really part of the radius. That's just part of the dimension. We could pull it over there for a moment. And we do need to make this a cut that comes through there. So let's make this cut bigger than it needs to be because there can be some unusual things happening here if you have like a 0 dimension cut. In other words, if I just made this shape like this, that line would go right through that point. So what I like to do on these is to make my cut too big, just cut through air, so to speak, like that, and then see if that helps. Now, if we feel like we really want to make, excuse me, if we really want to make this fully defined, we can just say, let's just make this an arbitrary distance above there of, I don't know, 0.1. It doesn't really matter how far that is. So now what you can see is that hopefully there's a shape here. The yellow line's kind of covering up the sides of that, unfortunately. And let's see if we can just cut through all of this at the same time. So doing this and going over here to cut, selecting that shape and this shape at the same time. We want to say we want to cut that way, and we want to go through all. Look at that. So we do all of it at one shot. It's a beautiful thing there. And now what we're going to do is do the height of this right here, C, so that's related back to D. We want to be 3/4 of that. So that means we need to come into here to this sketch that was on this plane. And you can find it over here in the feature tree, also called the browser, the model browser. And we need to change that equation. Now, I've already forgotten, though, what this initial one was. I think it was, yeah, wasn't it 6? So if we find that sketch, I think it's going to be here. Yep. Edit that right there. And I think it's going to be D6. There it is, D6. And you can just roll the changes back forward, even though we didn't really make any changes. And remember D6. And so what is the connection between D20 and D6? Well, it's going to be 3/4, right? So you can see the 3 and the 4. So we can do it 3 divided by 4. And it shouldn't change the size at all. Okay, D6 times 3 divided by 4. There we go. And so it didn't change anything at all, which is good. And then there's the function so that once we go back and change this height to be 3 units instead, everything should grow. All right, so let's commit to that change right there, make it look good. We're almost ready to turn it in, but we want to go back to that initial sketch and see if our parametric equations are going to work. We want to change that to 3, and hopefully everything is anchored properly so that it goes up. And that worked at least in that dimension also. We can hit finish right here, and you notice everything grew like it was supposed to. The bridge, I guess you could say, it got taller right there. This right here, the height right there got taller. This distance got taller. Everything seemed to work out well. And one of the things that we can also do is we don't have to go back to this initial one and edit the sketch there. We can instead go over here to where the parametric equations are under, is it manage? Is that where that's located? Yep, parameters like this. And if you click on that, it's going to look at all these dimensions that we have on there. And we're only really going to be interested in the ones that are equations. So some of these are just fixed constants. I wonder if we can actually filter down to ones that are just equations. So key, rename, okay, equation, look at that. How about that? So in other words, we can just filter down to the things that are not constant. If we show all of them, then we get this one right here. This dimension D21 is 0.5. So it's got all of them in there, but we just really want to see if our equations are all set up properly. I don't really know why this one's, oh yeah, I know why that was included, because that's the D6. And so all these other ones kind of depend upon that. Now, these other two are equations because I divided by 2, even though there's not really a D in there. I wonder if there's a filter for that. Probably not. But these are equations in the sense that there's no variables. It's just dividing by 2. And UL right here means unitless. So it's this distance right here divided by 4, no units, is giving us that distance over there. Everything looks great. Let's go ahead and hit save on this one and upload that one into D2L. And we demonstrated again that we have the ability to use parametric equations to auto scale some parts, but not all the parts. So, it might be a case where this anchors down to the ground. This is called anchor base. And you put bolts here into the concrete, and you might have like a hinge that goes over to the left and right. This one over here would handle a smaller beam going up and down. But if you wanted to give it a bigger distance right in this area here and more a clearance along the floor, then you've automatically scaled it. So that way your company is able to sell a variety of different sizes and not have to do a complete redesign of a part. They can just use parametric equations to size parts. Let's go on to this next one right here in the next video. So I'm going to stop right here and continue in a minute.